and I echo those sentiments. Here we go. Good morning, families. My name is Corey Gillette. I am the Assistant Superintendent for Curriculum and Instruction, and I'm very excited today to bring you the third parent informational workshop in our series of parent workshops this year. Dr. DeSantis started us off with a technology workshop, and then you heard from the 612 World Language Department about how we teach students to learn a language for life. And now you're going to hear from the K-12 Mathematics Department under the leadership of Jeff Corbishley, who's the 612 Math Science Supervisor, and Linda Johnson, who's the Elementary Director. And I just want to point out that this collaboration is a part of a focused effort since the spring of 21 to bring these teams together so that we are having aligned conversations that goes across levels. And I know, because I've seen a sneak peek of this presentation, that this presentation will show you how that alignment is working in a day-to-day way for your students at home. So I know you will enjoy it, and I'm going to turn it over to Jeff Corbishley, who's going to start us off.
Great, thank you, Corey. And welcome to everyone who's watching live, and to those who are watching a recording, also welcome. We hope that this presentation you find informative. There's a lot of people on this call that represent a lot of different areas. So I think we're ready to go. John, could you put up the first slide? Great. Thanks, John. So this presentation is a focus on how students learn mathematics in the Ridgefield Public Schools. So we've got a lot to focus on today. So I hope you're ready. If we could go to the next slide, because before we dive into today's session, I do want you to know that this is one of 2 math virtual parent workshops. So while this session focuses on how students learn mathematics, we will have an upcoming session on February 10th that deals specifically with the math placement process at our elementary and middle school. So we'll have a special session for 5th grade families at 9:30 a.m., as well as another session for 6th and 7th grade families at 10:30 a.m. So the next presentation will really talk about the placement process, the criteria, and the different math pathways. We do have a snow date of February 17th, just in case something comes along. But this presentation is really focusing on how students learn mathematics. So as Corey said, my name is Jeff Corbishley. I am the 612 Math Science Supervisor here in the Ridgefield Public Schools. And we do have a whole panel of people joining us today. So I'm going to ask if we could go to the next slide, please. I'm going to ask if Linda would take a moment just to introduce herself.
Good morning, everyone, and welcome. I am Linda Johnson, the Director of Elementary Education.
Great. Nancy.
Good morning, everyone. I am the principal at Farmingville Elementary School, and in a past life, I was a math specialist. So this is a really important topic for me.
Great. Thanks, Nancy. Amanda.
Hi, I'm Amanda Cody. I'm the math specialist at Farmingville Elementary School.
Great. And Bridget.
Hi, I'm Bridget Beskin, and I'm the math specialist at Veterans Park.
Great. Thanks, Bridget. Dee.
Hi, everyone. I'm Deidre Savage. I'm the department leader at Eastridge. I also teach 8th grade math in Math 8, Algebra, and Geometry.
Great. Thanks, Dee. And Keegan.
Hi, I'm Keegan Finlayson, probably the newest member of this group, new department chair at the high school, 16 years in education, and experienced in this, and I also teach AP Calc BC and Algebra 1.
Great. Thanks, Keegan. And I'm really excited. I've been part of the Ridgefield Public Schools for 14 years now. I was at the high school for many years as a teacher and department chair. So I'm really committed to the students and our mathematical progressions here in Ridgefield Public Schools. So I'm really excited we have this whole panel together to share their expertise about how students learn mathematics. So John, next slide, please. So we thought it would be good to start with this quote from Carol Dweck, whose research is really around the importance of a growth mindset. And for mathematics, that's really, really important. So if you look at this quote, there's a couple key words, including loves challenges, students that are intrigued by mistakes, enjoy effort, and keep on learning, right? The discipline of mathematics is really not just about memorizing and always getting the correct answer, right? Mathematics as a discipline is really about exploring ideas, trying new approaches, failing in those approaches, and then trying again, right? So while we're always seeking out a solution, right, the learning process is always about that need to continually explore around challenging tasks. So as we talk about our process at K-12, we want to remember that overall, that is what we're hoping we get out of a student's experience in mathematics. So the focus of our presentation today will really touch on three main areas. The first is we're going to look at a K-12 comprehensive approach to learning math and what it looks like in the Ridgefield Public Schools. Right, this approach is grounded in research for how we make sense of mathematics and build new understandings of mathematical concepts. We're then going to take a look at how this approach develops from our elementary, middle, and high school years. So we're going to follow a major mathematical concept around addition and see how that concept develops through the grade levels and how our approach for learning math is woven into our instruction. Right, we're then going to take a few moments to talk about how families can support their learners from home. We also sent out a questionnaire ahead of this session through our district communication. It's also listed in the description of this YouTube video as I'm speaking. So please feel free to use this form to submit any questions in real time. We're going to monitor them as they come in. We'll be sure to address these at the end of our session, or if they're individual in nature, we'll follow back up through email at the end of this presentation. If you're watching a recording of this video, we'll keep this questionnaire open for another week and be sure to follow back up with you. All right, so let's dive right in. Right, so we are looking first at how Ridgefield Public Schools has this comprehensive approach to math from the K-12 level. So we're going to dive into a certain key areas of this comprehensive approach. The first is really around the content standards, right? So our content standards on the next slide. Thanks, John. Right, the content standards are really what students learn in mathematics. So you can think about the content standards to include what students know and what they can do, right? So these standards are really from the Connecticut Core Math Standards, which are grounded in the Common Core Math Standards. So we do follow our state standards within all of our subjects. We ensure that there's vertical alignment between grades and courses. So one thing this presentation hopefully will show you is how we take a content idea like addition, and we vertically align that through the levels to build understanding. We know math is sequential in nature, so a lot of our curriculum itself is really designed in a way to build understanding all the way from kindergarten through 12th grade, and math doesn't have to stop there. It does go beyond if someone explores that in college. So those ideas will be a through line through what we're talking about today. The other thing about the content is really the content's built around the skills, mathematical facts, definitions, and concepts. So we really just want to think that the content standards are really designed to build a deep understanding around mathematical concepts. So at this point, I'm going to pass it off to Nancy, who will talk about another set of standards.
Thank you, Jeff. Good morning again, everyone. So as Jeff mentioned, you most often hear about the grade level course standards, but the mathematical practice standards are unique in that they are K-12 standards. So they are what we use to plan for how students are learning mathematics and how they're interacting with mathematics in the classroom. These practices really help us orchestrate productive mathematical discussions and build number sense in our students. Utilizing the math practices in the classroom makes learning visible and allows our students to engage in mathematical learning experiences that can be applied in everyday life. So this graphic may be familiar to you. We really like it here at RPS. So what this is kind of showing you is the gray bar on the side that shows mathematical practices 1 and 6 are really kind of the overarching practice standards. They're the umbrella. They talk about the habits of mind that we want our students to have when they're using these mathematical practices to solve problems. Then as you look to the right of that, you'll see that there are 3 boxes. So we kind of group the standards into ways that our students reason and explain, ways that they model and use tools, and how they see structure and patterns and look for generalizations in math. So the 8 mathematical practices span K-12, and they're reflected in our curriculum and in the curricular resources that we use all throughout RPS to ensure that every student has a consistent approach to learning mathematics. And with that, I'm going to pass it on to Linda.
Thank you, Nancy, and once again, welcome. Next, I'm going to briefly talk about the components of our comprehensive approach to teaching and learning mathematics, kindergarten through 12th grade. Then our math specialists and department leads will highlight examples at the elementary, middle, and high school levels. Our curriculum and instructional and assessment practices are linked to the 3 elements of rigor that you see here: conceptual understanding, procedural fluency, and real-life application. We value these components along with the 8 mathematical practices and the content standards that you just heard about equally. I'm going to speak a little bit about each component. Conceptual understanding refers to the comprehension of concepts, operations, and relations, and it stresses the importance of understanding what the concept means or the importance behind learning something. What's important to us as we're teaching math and students are learning it is that they understand why or the purpose for the learning. Then we have procedural fluency, which relates to the skills in terms of carrying out procedures flexibly, accurately, efficiently, and appropriately. We know that when students are accurate, they are able to find the correct answer. When students are efficient, they can solve a problem with a strategy that saves time or effort. When students are flexible, they know that they have multiple solution paths or multiple strategies that they can choose from. And then after that, they do choose the most appropriate strategy to solving a particular problem. And the third element of rigor is the application to real life situations, which we often refer to as problem solving tasks. And this is when students apply their conceptual understanding and procedural fluencies to solve a problem. And it's also an opportunity for them to apply their reasoning skills, critical thinking skills, and collaboration skills. And once again, the 8 mathematical practices are embedded in these 3 components of learning. Next slide, John. Okay, so the next part of our presentation is about how learning progresses from elementary to our secondary levels. Next slide. Our math coaches and department leads are going to share examples and insights of what conceptual understanding, fluency, and application look like in our classrooms. The examples focus on the concept of addition. And we're going to start out at the elementary level, where Amanda is going to talk about the conceptual understanding as it relates to addition. Amanda?
So when students are learning new math concepts, we want to introduce these concepts in a concrete and tangible way. So this involves manipulatives and objects that students can touch and physically move. So in terms of the concept of addition, students in first grade would be using a 10 frame, which is that rectangle in the first picture that's split into 10 boxes. And then when we're adding 9 plus 7, students can take 1 from the 7 and give it to the 9 to make a 10, and then see that 10 and 6 more, oh, that's 16. So that idea of unitizing to make a 10 is important as students progress through addition. And then moving into larger numbers, students might use unifix cubes, which they can break apart and stack together. And then looking at that example of 37 plus 8, you can take 3 cubes from the group of 8 to give that to the stack of 7 cubes to make a 10, which then leaves me with 4 groups of 10 and 5 more, so 45. And as students are developing their understanding of concrete models, it's important that we also have them draw visual representations of what they are doing with the concrete models. And these visual representations are the pictorial stage of a student's journey in learning a new math concept. And the concrete models and pictorial representations help move students to the abstract, which is would be just the addition equation written as only numbers, the way you and I were traditionally taught in school. But before students even stack numbers vertically and begin addition from right to left, the way we would, they'll work with expanded forms. So you'll see in that middle picture, they've stretched 48 to 40 plus 8, and then 33 to 30 plus 3. And this is helping students think about using place value to add the tens and the tens and the ones and the ones. They'll use partial sums, which is another important concept that students will revisit even as they progress in later years in math. And all of this leads up to the way you and I would think about addition with the standard algorithm, which you see in that third picture. And the standard algorithm is actually not expected to be mastered until the end of 3rd grade, again, revisited and honed in the beginning of 4th grade. So you won't typically see students using this as their go-to method until 4th or 5th grade. And now I'm going to pass it over to Bridget, who will talk a little bit more about elementary math.
Okay, thank you, Amanda. When students are taught standard-based mathematics concepts and practices, a lot of number fluency is also used to practice and apply these concepts. Many times when we think of fact fluency is brought up, images of flashcards and time tests pop up in our minds, but fact fluency has become very sophisticated in relation to mathematics. It's developed a great deal since the time of strictly memorizing any of the facts. And instead of memorizing the answers when you can easily forget them over time, we know a student is fluent in a fact when they can accurately, efficiently, and flexibly recall a fact. This usually happens in 3 phases. The first phase is when a student uses those concrete tools or their fingers, something that you saw in Amanda's slide, Unifix cubes, drawing them out to understand what's happening with some of the basic facts. For example, with addition and subtraction to 20, or multiplication and division within 100, and mental math strategies to help with larger numbers. Now, the second phase is when students have a desire to be more efficient and use more strategies, such as with addition, doubles plus 1, making 10, using 10. Thus begins the crucial phase of students knowing from memory and not just memorizing, which is not the same. And sometimes I explain to the students that memorization is kind of fleeting, and you may forget it easily, and it's only 2-dimensional, where knowing from memory is 3-dimensional and has a lot of depth and skills we can pull out. And so the extensive use of strategies in this phase helps a lot with games and practice until the student knows it's so familiar with the fact that they just know it, and flexible thinking is present. The last stage is when a student can recall the fact through practicing using strategies and being flexible with other facts to perhaps use it to attain the answer, while visualizing the facts in their heads, and with that comes accuracy, efficiency, and flexibility. So we're going to go to the next slide. So within the elementary years, these students use the concepts that were being taught, and they're asked to apply their knowledge and concepts. They're intertwined within the daily lessons and progress in difficulty over the years. In these examples, the 1st grade is working on using their knowledge of basic facts within 10 in a word problem. In grade 3, their work with 3-digit numbers will allow them to be a little bit more flexible with their problem solving, and it becomes a lot more challenging. And grade 5 starts to use addition and subtraction concepts of fractions. So within each grade, there's a variety of levels and opportunities to apply what they have learned. And now I'm gonna, Jen, next slide.
Thank you so much. So again, I'm Deidre Savage. I'm the department leader at Eastridge, and we are always so grateful to our amazing elementary team for setting up our students for success in the middle school mathematics paths. So go ahead, John. So what's really exciting about math in the middle school is students are beginning their algebra journey. And one of my favorite phrases in math that I say all the time to my students is, all roads lead to algebra. So really, success in higher level math really comes down to having great fluency and great algebraic understanding. So in 6th grade, when we are talking about the concept of addition, there's no real new learning that happens for addition, but we start using addition of positive numbers in an algebraic context. And again, we use models and we use pictures. So in the 6th grade example, we're talking about combining like terms. So teachers will use pictures such as the ones you've seen. We use a lot of color coding strategies to help students as well. In 7th grade, we continue the idea of addition, but we introduced negative rational numbers. So now we're talking about negative fractions, negative decimals, negative whole numbers. We use our integer counters, those red and yellow circles that you see shown there, to really help students visualize the idea of what it means to add and subtract a negative number. As was mentioned earlier, instead of having students memorize those rules for integer addition, as was said so eloquently, memorization is fleeting, right? So really having them understand why addition of integers is really adding the opposite sign, those counters really come into play and really help students solidify that understanding. And in 8th grade, the example here is an example of a systems of equations, and there's lots of methods to solve a system, and we teach all 3 methods, but the idea of a model in algebra and in Math 8 is really the idea of a graph, and students understanding what is a solution truly in a problem and modeling it through graphs. Next slide, John. So then when we talk about fluency, we're really starting to slowly take away those physical manipulatives. So in 6th grade, we take away the photos, but we're still allowing students that color differentiation of circling, boxing, underlining those like terms. And students are really able to kind of move through those problems more efficiently and accurately. In 7th grade, we introduced the super important concept of solving equations, and this is where structure is really introduced and really reinforced as a good strategy for solving any type of problem, and being fluent in your work is keeping a nice solid structure in your math work. And in 8th grade, again, an example of solving systems of equations, this time not using a graph. This is by elimination, which is, again, embedded addition. So students are really forced to slow down, use their structure, and make sure that they are understanding those negative integer rules from 7th grade in order to solve problems efficiently and accurately. Next slide, John. And then, of course, I think as a math teacher, one of the most popular questions we get is, when are we ever going to use this, right? So application problems are so important in getting students to make connections to what we're doing in our classrooms to their real life. Of course, they always love to say no one's going to go buy 20 watermelons, but of course, we try to make our problems more relevant. So in 6th grade, really having students again dip into that algebra realm with variables and writing expressions for problems. In 7th grade, this example is talking about making a fence for a yard, so that idea of perimeter. And then in 8th grade, again, keeping with systems of equations, asking how much of each type of food you can buy if you only have a certain amount of money. So getting students to really apply their knowledge in non-rote scenarios is really where we can see their understanding of the topic. And I'm going to pass it to Keegan.
Thank you very much. So in high school, the concept of addition gets expanded well beyond just simply adding numbers or even adding the terms that Dee was talking about. We also make sure that they understand that addition is and subtraction are really the same, that we can combine, we can call that combining terms. And so we are looking at expanding to addition in measurements and functions, complex numbers, probabilities, all of those can include addition. Fluency for us is based on choosing when and how to apply addition concepts in new situations, and determining if addition is an effective strategy. Not all strategies that might look at additive are in fact additive. It is now more often embedded in a larger process, and it can change depending on the objective within the problem. Applications may sometimes not have that real world connection that they might have had in the middle school. Sometimes the applications are now becoming more multifaceted and complex. There are still those realistic applications, including addition, but at times addition can take on a very abstract meaning that might be applied later on down the road. Next slide, please. Rather than looking at all the different places that addition can happen. This is just kind of a sampling of the kinds of things that we would see at the high school level. We have 3 core classes that everyone takes: Algebra 1, Algebra 2, and Geometry. And of course, we have the higher level classes, and addition is going to have applications all the way through. So here are some of the ways that addition can be used in these major topics. In algebra, much like at the middle school, because they do also teach the algebra, students learn what a function is and that 2 or more functions can be added. For instance, one function may describe revenue and another one might describe expenses. And so the combination of those 2 would describe a net profit. In geometry, students can use angle and segment addition postulates. They can find the areas of complex regions by adding smaller regions and use trigonometry with the sum of angles. In Algebra 2, students are introduced to rational functions and how to add these functions, which is very similar to what they would have learned in 4th and 5th grade when they were doing the addition of fractions. Next slide, please. So here are some additional courses that we teach outside of the core that students can take. In pre-calculus, we might be doing things like adding vectors or matrices or other mathematical objects where things are no longer just simply adding numbers. Vector addition can be used for adding complex numbers, and they are which are numbers that are not part of our everyday real number system. Probability uses ideas of set and union of sets. So now we have addition and union being combined into a concept, and that can be applied to find the probability of multiple events occurring. In calculus, students study integration, and for anyone who has studied calculus, they know that integration essentially is infinitesimal addition. And I put on there the symbol for integration, which is the elongated S, standing for summa or sum of numbers. Next slide, please. So just like in every other school at every other level, fluency includes that accuracy, efficiency, flexibility piece. So addition, in the more advanced topics, speed is not the key to good comprehension and problem solving. It says students must make choices in how they are working towards an objective, and there might be multiple pathways towards that objective. In geometry, for instance, students need to decide if using the sine of summed angles would actually help them in an application. And you can see one of those applications there. Applying the sum identity also requires accuracy. Looking at polynomials as a summation can reveal different aspects of a function. And so you can see that in algebra. Looking at multiple representations can demonstrate flexibility in students' thinking. And in calculus, students use what are called Taylor series, which are shown in this summation notation here, addition of all these terms, and to understand the differentiation and integration of complex functions, which is a lot of words if you haven't taken calculus, but really makes a lot of sense when you're actually in the process. Next slide, please. So here are some of the applications that we see in 9 to 12. So here are some of the ways that we're combining values. For instance, in geometry and trigonometry, to find the distance across a river, you need to know that in this example, x plus 150 is the entire length of the bottom of this triangle. In algebra, you can see the process of completing the square using algebra tiles. Again, that manipulative that is actually used even before this point. But with that physical application, you can see the addition. And if you were to look at this picture, you can see exactly what is the missing piece, which is completing the square. In calculus, and the answer, by the way, is 9 in case you didn't you needed that information. In calculus, the distance along a curve can be seen as the sum of infinitely many small distances along the curve. So we have these applications that show up that really bridge all the way back to the elementary level, all the way up through high school and even beyond. So with that, I will pass it off to Nancy, who will be discussing the homeschool connection.
Thank you so much, Keegan. You are making me miss high school math. Yes, so we're going to take a few minutes just to talk about how you can help your students learn math concepts and skills and strategies at home and in the real world. Next slide, please. Thank you. So this slide circles back to two important things. It circles back to the mathematical practices that we looked at earlier, as well as the quote from Carol Dweck, who reminds us to teach our children to love challenges, be intrigued by mistakes, enjoy effort, and keep on learning. So how can you help your student at home? One of the best ways that you can do that is to really put math into the context of the real world and your home for them. You can ask them questions like the ones you see here. What do you notice? How did you figure that out? Do you see any patterns? Or even, does that make sense? Why does that work? You can continue to build your child's conceptual understanding by using some routines that we use in school every day, such as noticing and wondering. Like I said, your children are familiar with that. So you can ask them, what do they notice and what do they wonder about multiple situations? You can also use their passions to incorporate math. You can play card games and board games and do puzzles, because those involve strategy and planning and modifying and analyzing, which will help with math. And of course, it's important to monitor their work that comes home from school, reach out to their teacher with questions, and remind your kids that mistakes help us learn, and that's how we continue to grow. Oftentimes, one of the most common questions we hear is there a particular website or resource that we can go to if we have a question about our child's homework or about how they're learning math. And truthfully, the best resource that you have is your child's teacher. So please reach out to them anytime. They know what your child is learning and how they are learning it, and they're always willing to help. We did receive a few extra questions, and my colleagues have already answered those to you individually. You probably received an email from Linda or Jeff, and they're going to keep that open, and we'll continue to respond individually to any questions that come after this live recording. And we hope you enjoyed being here with us. And on that note, I'm going to pass it back to Linda.
Thank you, team. So hopefully through this presentation, you were able to see the through line of how we really do value teaching grade level standards, our 8 mathematical practices. We did provide you with an opportunity to learn a little bit more about our comprehensive approach to teaching mathematics through conceptual understanding, computational fluency, and then that real life application piece. And our math specialists, along with our department leads, did provide you with examples using the content of addition, so that you could see that learning progression all the way from kindergarten through 12th grade. And Nancy, thanks so much for giving us those suggestions on home links. And most importantly, as Nancy mentioned, if you do have a specific question about your student, about your learner, please do not hesitate to reach out to your classroom teacher in your school, and whether it's your math teacher at the secondary level, math teacher at the elementary level. Our teachers really do want to hear from our parents and how they could further support students with learning mathematics. So that being said, again, for those of you who did submit questions prior to our presentation this morning, Jeff or I have reached out to us, and don't hesitate to reach out to us with more questions. And I'm just going to check to see if any questions did come in during the presentation, because we did leave that question form open. And it looks like right now we don't have any other further questions that came in during our presentation this morning. But again, we are going to leave the question form open until sometime next week. So as you're watching this presentation, if a question did come to you, or if something comes up during the week, don't hesitate to put the question on our form. Jeff and I will make sure that we keep checking back in on any new questions that come in, and we'll make sure that we get back to parents. And then if this recording is also going to be available on our curriculum website YouTube channel. So if you didn't get to view it today, or if you have some friends out there who might want to see it, please let them know that it's accessible through our YouTube, and we'll leave that form up, that question form up there as well. All right. So that brings an end to our presentation this morning. Again, thank you to the team for all the wonderful information that you shared this morning. And thanks to our community out there for joining us. And we are here for any future questions.